Hi, I'm Hui, and I'm going to present our work on shortcut gestures for mobile text editing. I worked on this at the University of Stuttgart together with Sven from the LMU Munich, Max, Jonas and Henrike from the University of Stuttgart, and Niels from the University of Regensburg. Advances in mobile text entry enable smartphone users to type almost as fast as on physical desktop keyboards. However, text-heavy activities such as word processing and programming are still not widely adopted on smartphones yet. One reason is the lack of shortcut mechanisms that allow the user to quickly navigate and edit text. Expert users perform hundreds of shortcuts on a physical keyboard per day, which are not available on smartphones. While dwell times and context menus are often used for shortcuts, they are slower than their keyboard counterparts and overload the user interface. In our previous work, we presented InfiniTouch, a fully touch-sensitive smartphone that allows users to perform input on the whole device surface. Driven by a neural network, our prototype distinguishes between inputs of different fingers and uses the state of certain fingers as an action modifier, very similar to modifier keys on physical keyboards. In this work, we build upon this prototype and elicit, implement, and evaluate a gesture set that offers access to common text editing shortcuts. The first step is to understand which shortcuts expert users regularly use. We conducted an in-the-wild study in which we collected shortcuts performed by 15 expert users over 5 workdays. We captured over 67,000 keyboard shortcuts from our participants, which resulted in 96 unique keyboard shortcuts for which we determined their effect based on the foreground application. From this study, we learned that expert users perform almost 800 keyboard shortcuts on average per day, many for cursor navigation, text selection, clipboard management, and to switch between applications. You can find a full breakdown of all keyboard shortcuts in our paper. The second step is to understand how users prefer to perform shortcuts on a fully touch-sensitive smartphone to access frequently used functions. We conducted a gesture elicitation study with 18 right-handed participants and showed them 22 distinct references based on our findings of the first study. We used the formal method for gesture elicitation studies by Warburg et al. And showed participants the before state and the after state of a shortcut, and then asked them to come up with a gesture. We gave them a smartphone that we treated as a magic brick that is able to recognize any gesture. We derived the gesture set using the Agreement Analysis Toolkit. In the next step, we developed a model to recognize the gesture set on the fully touch-sensitive smartphone. Our prototype has capacitive sensors around the whole device surface, which senses the grip and the hand movement of the user. We conducted a study with 28 participants to collect raw data from the capacitive sensors where they performed gestures. Using this data, we trained a CNN LSTM that recognizes all 12 gesture classes with a test accuracy of 81%. This model runs on our prototype and can now be used to place the text cursor, select text, manage the clipboard, and switch between applications. We evaluated our system with 12 participants who have not participated in any of our previous studies. In this evaluation, we focused on validating the model accuracy, have new participants rate our gesture set, and collect subjective feedback on the overall system. We found that our model is generalizing well and did not overfit to the participants of our previous study. Further, the subjective feedback showed that participants are positive towards our gesture set. Compared to recent ways to place a cursor and select text on Android systems, our participants found that our gesture set is superior in terms of easiness, speed, comfort, suitability, and effort. The same applies to clipboard access. However, our participants still prefer to switch tabs using direct touch instead of a gesture. For a full overview of all quantitative and qualitative results, please read our paper. In summary, we elicited, implemented, and evaluated a gesture set for text editing shortcuts on a fully touch-sensing smartphone. Our participants perceived our approach of providing shortcuts as easier, faster, and more convenient compared to recent methods on smartphones. Thank you.